So for any quadratic equation written in this form, sometimes they call this standard quadratic form. It actually has different names depending on which textbook you're using. So you need to pay attention to your book. But the vertex, if it's written in this form, is always going to be HK. Change the first sign, keep the second. The domain for a quadratic is always negative infinity to infinity. The range is either from K to infinity, and you would include K, so put a bracket there. If A is greater than 0, or it's negative infinity to K inclusive if A is less than 0. Whether it has a maximum or a minimum, again, depends on whether A is a positive, negative, or negative. If A is a positive number, then it means that it's opening up like this. So it has a minimum. If A is less than 0, that means it's opening down because it's being reflected across the x-axis. In that case, it has a maximum. It is always at the vertex, guaranteed. So the minimum y value is K, or the maximum y value is K. And it occurs at x equal to h, whatever h is. When you talk about the intercepts are a lot easier to find if it's multiplied out in the form ax squared plus bx plus c. The y-intercept is always the value that you get when you let x equal 0. So if you've got this and you let x equal 0, then you've got a times 0 squared plus b times 0 plus c. So the y-intercept is always going to be at the point 0, c. Some textbooks require you to fill out the whole thing as a point. Some of them just want the c. If you are specifying that it is the y-intercept, the point where it crosses the y-axis, then you can just call it c. It's the c on the y-axis. Now the x-intercept is a lot trickier. If we let y equal 0, then we're dealing with ax squared plus bx plus c equals 0. And if this looks kind of familiar, it's because the solution to this is the quadratic formula. So the solutions, it'll have two. The solutions are negative b plus or minus the square root of b squared minus 4ac all over 2a. This, however, that's these 2 points. One of these points is negative b plus the square root. The other one is the negative b minus the square root. And if you look at this, here's your y-intercept, 0c. Here's your x-intercepts. And if b squared minus 4ac turns out to be a negative number, that means it doesn't have any real x-intercepts. So either you've got a case where it is above the axis and stays there, or it's below the axis forever and it never goes through the x-intercept, the x-axis. So this would be a situation where you get a negative, where I can say b squared minus 4ac is less than 0. That's your discriminant. But there's another secret about this. If you add these two together and get their average, if you add them together and divide by 2 to get their average, and I've split this up as 2 different fractions on purpose, if I add negative b over 2a minus this fraction to negative b over 2a plus this fraction, the fractions cancel, and I end up with negative b over 2a plus another negative b over 2a, which would be 2 negative b over 2a's. Then I divide by 2 to get the average, and I end up with x equals negative b over 2a as the average of these two values. Now, what that means, the line that goes down through the parabola and cuts it in half is called the axis symmetry. And the equation of the axis symmetry, because it's always got to fall halfway between the x-intercepts, the equation is x equals negative b over 2a. That's the equation of the vertical line going down through the middle of the vertex. Well, if this is the point negative b over 2a along the x-axis, then the vertex has as its x value negative b over 2a. There's also a formula that you could use to get the y value, but it's actually easier to just get the y value for the vertex by plugging whatever negative b over 2a turns out to be back into the original function. So we usually just write the y value as f of negative b over 2a. Now, if you have a quadratic function in this form, and they want you to put it in the other form, where you can see what the vertex is, they will usually teach you to go through a process called completing the square, which sometimes is not too hard, but sometimes it can be really complicated. The easier way to put it in the standard form, instead of putting it in the standard form to find the vertex, you can always use this to find your vertex, and then take this and plug that into where the h and the k go. So you take the y equals a, which will be exactly the same a as this one. Whatever this a is will be the exact same a. That's why they can use a both times, but they can't use a, b, and c to represent the vertex. So it's going to be a times x minus h squared plus k. H is negative b over 2a. Whatever that turns out to be, plug it in right here. K is the y value that you get when you plug that in. For example, suppose we were given f of x equals x squared minus 8x plus 12. And they asked us to find the vertex, domain, range, y-intercept, and the x-intercepts. And of course, graph it. Now, they'll probably say first to put it in the standard form, the y equals a times x minus h squared plus k form. So the standard form is the first thing they're going to ask for before they ever ask for the vertex. You can outsmart them. This is A equals 1, B equals -8, C equals 12. So H is going to be -b over 2a. So it's a -8 over 2 times 1 is 8 over 2, which is 4. So I know the x value for the vertex is going to be 4. To get the y value, plug that back in. So k is going to be whatever we get when we plug 4 into the original equation. So 4 squared minus 8 times 4 plus 12, 16 minus 32 plus 12. Let's see, 16 and 32 is 28. 28 minus 32 is -4. So k is going to equal -4. A is 1 under any circumstances. So the standard form here is f of x equals 1 times x minus 4 squared minus 4. Remember, change the first sign, keep the second. So they want you to do this first and then find the vertex, but I promise you it's easier to find the vertex and then do this. Your domain is always -infinity to infinity. Your range, A is a positive number, so this goes up. Here's your point negative, here's your point 4, -4. So the range is your y values. It goes up. So the range is going to be from -4 to infinity. The y-intercept is when x is 0, wipes out that, wipes out that. That's going to be 12. So you can put 12, or you may have to put the point 0, 12. Depends on your teacher, depends on your book. The x-intercept. The x-intercept is what you get when you set this equal to 0. And you can, of course, use the quadratic formula. But I believe this is going to factor, so I'm going to try that. Quadratic formula will give you exactly the same answers. So the factors of 12 that add up to 8 would be 2 and 6. To get a -8, it has to be a -2 and a -6. If I put x minus 2 is 0 and x minus 6 is 0, then I'm going to get x is 2 and x is 6. So the y-intercept, so it's the 0.20 and the 0.60. And the graph, for the graph, the vertex is 1, 2, 3, 4, 1, 2, 3, 4. Here's the vertex. The y-intercept is at +12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 up here. The x-intercept, one is at 0, at 2, 0. Here's the 4, 5, 6. The other one is at 6, 0. I know I've got my axis symmetry is through here. So I'm going to have another point straight across from here, the same distance from the from the axis symmetry. So that's really crooked. It's very hard to write a nice line on this, but that's my graph. And that's how you do it. That covers the whole thing. So let me know if you have any questions, and I will talk to you later.